Hello, I'm Alex Alvarez and welcome to Dynamics 8. In this lecture we're going to get started with softbodies, which are a way to take NURBS or polysurfaces and replace the vertices with particles so that pretty much everything that you understand about particle behavior, such as fields, goals, or emitters, can be applied to surfaces to create a really wide variety of effects. And so in this lecture we're going to look at some of these simpler effects to create things such as cloth type objects. We're going to look at making a curtain, we're going to make a tablecloth, and we're also going to work on a cape. And then we're also going to look at a couple other effects such as creating a candle flame and also taking a character that's skinned and getting regions of its skin to behave with secondary jiggle so that you could have cheeks or a belly or any region of a character that as the character takes a step or shakes his head, get that secondary movement in the skin that is really necessary to create natural behavior. So that's where we're going to get started, and we're also going to take a look at springs, which are a crucial component of soft bodies to keep things together so that when you create springs between particles, if one particle moves, surrounding particles will move with it, and that creates ripples through your soft body that can be really cool. So we're going to start there, and hope you enjoy the lecture. So to get started with soft bodies, we're going to take a look at this balloon example where we can see that we have this balloon that's getting emitted out of this hose, and this is going to allow us to look at a lot of the different concepts for soft bodies so that we can then move on into a bunch of other examples. And so with something like this, if we jump over to Maya, we can see that we have a combination of just regular animated geometry as well as a soft body. So the hose and the fixture, these are animated just using a spline handle and a sculpt deformer. So that if we go and hit play, what's happening is we can see that there is simply a skeleton inside here that this geometry is bound to for this hose. And then that skeleton is sliding along a spline handle, so we can see there's a curve inside here. And then also there's the sculpt deformer, and that sculpt deformer is simply moving along that curve as a motion path. And so we can see that as that sculpt deformer moves along that curve, we're getting that kind of bulge. And so that's just sort of regular animation stuff in Maya. But as far as the soft body, let's now go in and focus in on what's happening here. First, we'll see that the balloon is being born or emitted out of the end of the hose. And we can also see that it's going and behaving with a, let's say, secondary motion type of behavior where it's jiggling and bouncing forwards and backwards. And with something like that, that's sort of the nature of soft bodies versus rigid bodies, where with rigid body dynamics, geometry does not change shape as a result of the event. And so inside here, what I'm going to do is we're going to take this apart and then put it back together again. So I'm going to hide the whole little rigging inside there. So now we can see we just have an emitter and then the balloon that's being emitted out of that. And so to take this apart, I'm just going to delete our soft body balloon, and I can also delete the emitter. But what we'll see is that in the scene I still have my original balloon, which is hidden right now, and I'm just going to get that to be visible. And so at this point we have our geometry, and this is just a simple piece of NURBS geometry. And so we can see that it doesn't have too many vertices, it's relatively simple, and then also with it, it doesn't have any construction history, so there's no history on this object. You can turn something into a soft body that has history, it's just in this case we're not. And so with this balloon, our original balloon, we want to go in and figure out how the soft body engine works. So right now I hit play, there's nothing going on. And so I'm going to select the geometry and go to the soft/rigid body pull down menu. And in here we can see we have create active or create passive rigid body. Then down here we have create soft body. So the main difference is they just use different engines. The rigid body engine has its own way of working where if I select something, let's say like this balloon, and let's say we turn it into an active rigid body, apply gravity to it, and then let's say create a simple ground plane that we turn into a passive rigid body. If I hit play, and let's actually go in here and just rotate the balloon a little bit, we can see the result that we're getting. So this is rigid body dynamics, which basically means that the object does not change shape and cannot change shape as a result of the collision. And so for soft bodies, let's go in and let's go back a couple steps. Let's get rid of the rigid body node on that balloon. And now let's select it and turn it into a soft body instead. And so we're just going to select the geometry, go to the soft/rigid body pull down menu, and say create soft body. And in the option box, I'm going to hit reset. And the default settings, it says creation options make soft, but all of the checkboxes are grayed out. We can't access them. Well, there's a pop-up menu here where we have make soft and then some other options. Duplicate, make copy soft, duplicate, make original soft. Well, just using the default options, make soft, let's hit create. And what happens is we'll see that we now get particles which have appeared at the location of all of the vertices of the geometry. So nothing new seems to have been created in the outliner, but we definitely have some particles in here. And if I take the particles, I can switch their display type to spheres, so they're a little bit easier to see. So the particle object that's been created is a normal particle object. Everything you can do with particles, you can do with particles that are created with the soft body tool. So there's nothing really special about them. It's just they have some default intrinsic behavior, which is the fact that the vertices of the original geometry are now constrained to these particles. So if we go and look in the hypergraph, what we're going to see in here is, let me just get display show shape nodes, so that here's the original balloon and its shape node, but then in here we'll see we now have a particle transform node and a particle shape node. And so at the same level of the shape node for the geometry, we now have a particle object. And we can also see that sitting in here in the channel box. So this particle object is completely normal, meaning that you could render it. All the fields and all of the regular particle techniques are going to work with this particle object. It's just very often, or usually with soft bodies, the purpose of the particles is to determine the behavior or the movement of your piece of geometry. Usually you're not going to render the particles of a soft body. Sometimes you might, for certain types of effects, if you just need to replace geometry with particles very quickly and you don't care about the geometry. But in this case, we're more interested in what the balloon geometry does. So if I now take these particles, let's say we apply a field to them. So I'm going to say field, and let's create a vortex field. And for the vortex field, I'm going to just turn it to the default options. And if we hit play, what we're going to see is the particles are going to start to spin around, and therefore the vertices of the sphere or the balloon are going to start to spin around. So let's increase the magnitude a little bit of that vortex field. And as we increase the magnitude, it's just going to speed things up a little bit. But the thing to point out now is we can see that this is all working, but the issue is our balloon needs to behave like a balloon. And if I go and have, let's say, a field like a vortex field turn on for a second, that's fine. But let's say what's going to happen if I turn the vortex field off. So let's go and set a keyframe on our vortex field. So it's on at frame 1, but then turns off by frame 20. And I'll play this back. What happens is when the vortex field turns off, the particles continue to move. And they're continuing to move because they do not have any intrinsic shape to them or any intrinsic behavior. They're just going to behave the way regular particles would. I could get it so that the particles slow down and stop if the vortex field turns off, just by taking the particles and lowering their conserve. Let's say I put the conserve momentum attribute to 0.9 on the particles. If I now hit play, you'll see that when the vortex field turns off, the particles slow down and stop. But the balloon does not return to its default or initial shape. So when you're working with soft bodies, you have to decide what type of material you're trying to create. With something like a balloon or anything made out of rubber, or something like skin and flesh, those are things that always return to the same shape after they've been deformed. So if you take a rubber ball and you squeeze it and you let go, it's always going to return to its same shape. Different types of rubbers might take a different amount of time to return to their default shape, but they eventually will. Same thing with something like skin. If you have your belly, if you jump up and down, it's going to jiggle, but when you stop moving, it's going to come to rest. Something like a water surface. If you have a pool that's 10 feet deep and you shake or add turbulence to the water surface and then turn the turbulence off, that water surface will always come to rest in the same position. So those are cases where you do have an intrinsic shape, and that's when you're going to need to use goals with these particles. And in this case, when we chose make soft, we didn't have any options that specified any type of goal behavior. So objects that don't necessarily need goals would be something like, let's say, a thin piece of material or fabric like silk, where you could pick it up from any corner and it's always going to take a different shape. And so the intrinsic shape in something like some certain types of fabrics or cloth is going to be a little different. So we'll look at a bunch of examples that show different cases for different types of techniques. But in this case, we definitely need this balloon to have a default shape. So we're going to delete the particle object that's in here so that now we just have a regular piece of geometry again. And now we'll select it for a second time and go to the Create Softbody options. And this time we're going to choose Duplicate, Make Copy Soft. And if we blow this up a little bit, we can see that when you choose Duplicate, Make Copy Soft or Duplicate, Make Original Soft, you now have access to these checkboxes that are in here. And so the checkboxes we have are Duplicate Upstream Graph, Hide Non-Soft Object, and Make Non-Soft a Goal. Duplicate Upstream Graph. Well, if you say Duplicate, Make Copy Soft, it literally means it's going to take the balloon, make a copy of it, and then the copy of the balloon is going to be the one that's soft, meaning that's the one that has the particles. If you choose Duplicate Upstream Graph, it means that when it copies the balloon, that any input connections that the balloon has, like any construction history, will be copied. The whole upstream graph would be copied to the duplicate. If you choose Hide Non-Soft Object, it just means the original balloon is going to be hidden. And if we choose Make Non-Soft a Goal, it means that the original balloon is going to become a goal for the copy which has the particles. And that's the crucial thing that you're going to use a lot, because by using goals, you can have the original balloon be a target shape for the soft balloon, so that the soft balloon will always keep up with whatever the original balloon's doing, but there'll always be some sort of lag based on this slider we have here, which is called weight, or goal weight. So jumping back to Maya, what we're going to do is say Duplicate, Make Copy Soft, Hide Non-Soft Object, and Make Non-Soft a Goal. And the weight value is at 0.5 right now, and we'll just leave it at the default and hit Create. What we'll see is that we now have our original balloon in the outliner, but we also have a copy of the balloon. If I select the original balloon and try and move it, you'll notice that we don't see it because it's been hidden. Then, the copy of the original balloon is the one that has the particles. And if I select the particles, let's just get them to be spheres. And also, if I go to the attribute editor for these particles, I can change the radius of the spheres, because again, they're just normal particles. Make them a little smaller. And so, what's going to be the difference now? Well, basically, if I hit play, everything's going to look the same, or rather, nothing's going to change. But if I go and take my original balloon, and let's go to Display, Show Selection, so that now we can see it again, I'm going to put some animation on the original balloon. So I'm going to keyframe it at frame 1. I'm going to rotate it at 90 degrees, key it again, and then I'm going to rotate it back to its original position at 0 at frame 30. So if I go and hide my soft balloon for a second, if we hit play, we're going to see this. So just simple keyframes on our original balloon. But then what I'm going to do is hide the original balloon and then get the copy, the one that's soft, the one with the particles, to be visible. And now if I hit play, we'll see this. You'll notice that the soft balloon is trying to keep up with the original balloon. And so let's hide the original balloon. I've keyframed the visibility to on, so let me just delete the keyframes on the visibility of the original balloon, and then I can hide it. And so now when we hit play, we've got this. So now we're getting soft behavior. The original one moves, and then the particles on the copy try and keep up. And so if we select the particles, you'll see that there is an attribute called goal weight, which you can access either in the channel box or via the attribute editor, where you'll see there's a folder called goal weights and objects for the particles. And so if I go in here and I change the goal weight, if I put the goal weight to a value of 0, it means that the particles will no longer see the goal, which means that if I hit play, the particles are not going to move. If I put the goal weight to a value of 1, the particles will be completely locked onto their goal, which means that whatever the original balloon does, the soft balloon will do exactly. So if I put the goal weight back to 0.5, then we get the soft behavior. So the higher the goal weight, the stiffer the soft body. So if we decide that this balloon is a little bit too jiggly right now, I'll just put the goal weight to 0.7. And now you can see it comes to rest a little bit faster. And so all of this is just based on what kind of material you're trying to represent. So now with my goal weight set, hopefully you can understand basics of this engine. But now we need to point out the fact that the goal weight that we've been editing in the channel box is affecting the behavior of all of the particles in this particle object. And so what we want to do is determine how we can set goal weight on a per particle basis. And what you will see is whenever you turn something into a soft body and you get soft body particles, or whenever you go and use the regular goal tool with particles, your particles will always have an attribute added called goal PP. And if I select the particles and go to the attribute editor, you'll see that there's a folder in here called per particle array attributes. And if I open that up, you'll see in here that there is a field that says goal PP. So that literally means that every single one of these particles has a goal PP value, which I can write a creation expression on, I can write a runtime expression, I could use ramps, all of the regular particle stuff, or I can use the component editor. So if I went into component mode and selected some particles, you'll see I can select individual particles like this. I can select some of them, go to the component editor, go to the particle tab, and you will see that the particles have goal PP. Every single particle's default goal PP value is 1. And so basically what's going on in here is the goal PP is multiplied by the goal weight that you see in the channel box. So the goal weight in the channel box you could think of as being goal PO for per object, and then in here we're seeing goal PP. So if we decide that we want to set our goals on a per particle basis so that some regions of the balloon can be stiffer than other regions of the balloon, then we might set the goal weight to a value of 1 in the channel box, so that whatever values we enter in the component editor are the values that we're actually going to get. So I'm going to go to the component editor. Now that I've set the goal weight to 1, I'm going to grab the ones at the bottom, and you'll see they already have a goal PP of 1. So that means that they're going to be very stiff and very rigid. Then I'll grab the next row of particles, and I'll put the goal PP to 0.9. Then the next row, 0.8. And the next one, 0.7. And then the next one, I'll put to 0.6. By doing this, I'm effectively making the top of the balloon softer than the bottom of the balloon. And so since our balloon doesn't have that many vertices, this is a relatively straightforward process, setting per particle goals using the component editor. And so if we want to see what's going to happen if we play back the animation now, let's go back to frame 1 and hit play. And so now you should be able to notice that the top of the balloon is softer than the bottom of the balloon. And so I could go in here now and let's get those particles out of the way. So I'll switch them back to point mode. And I'll also increase the display res of the balloon so it's a little smoother. And so now we can see that we've got this sort of jiggly balloon that's jiggly at the top, not at the bottom. If I wanted to magnify the effect, I could select the particles and change the goal weight. So the goal weight's at 1 right now. If I put the goal weight to 0.5, it's going to multiply 0.5 by the goal weights that are on all of the particles on a per particle basis. So now it made the whole thing a lot softer and exaggerated the effect. So now let's put the goal weight to 0.7. And now we can see it's going to get stiffer. So by balancing the goal weight that you have per object, the goal weight in the channel box, and the goal PP, you can get a variety of effects. So you can see if this was something like a character, for example, you might want the cheeks to be soft, but the forehead to be stiff. Or you might want the knee and the elbows to be stiff, but the fleshier parts of the arms and the legs to get softer. But if you do have a case like that where you're dealing with a character, or you're just dealing with, let's say, even a balloon or a piece of geometry that has more vertices than this does, be aware that when you're working with goal PP, if there's too many vertices for it to be intuitive as far as editing the values on a per particle basis, you can select the soft body geometry and go to Modify Attribute Paint Tool, which will allow you to use Artisan to paint your goal PP. If I go to the options, you'll see automatically my balloon switches into a grayscale mode where the value being displayed is my goals. And so at the bottom, you'll see the balloon is white because my goal PP is at 1. And so if I wanted to go in here and lower the goal weights overall, I could say scale by a value of 0.75 flood. It made the whole balloon darker, but then I could go and say replace with a value of 1 and maybe get the bottom to be white again. And so if I go inside here, we'll see that I'm painting my goal PP by just dragging inside here. So I can just drag around. So now the bottom of my balloon is going to have a goal PP of 1, and the rest of it has had the goal PP lowered. And then we could go to our balloon, put the goal weight back to a value of 1 in the channel box, but we're still going to get this exaggerated behavior. Now be aware in here that you can see that when I hit play, there are a couple vertices at the top of the balloon that didn't get the exact same goal. And when you have something like this revolved surface, we actually have several vertices on top of each other at the top. So for that, you might choose to fix that by just jumping just for those points into the component editor. So I'm selecting all of the particles that are at the pole, going to the component editor, and I can see that they do not all have the same goal weight. So I'm going to give them all a value of 0.45 so that we don't get our pole breaking apart. And so now if we go back out here, that isn't breaking apart. Now we can see that we do have this one vertex, or rather particle, that also doesn't have the same goal as its surrounding particles. And so I'll clean that up as well. That just has to do with what I did with Artisan. And so you just have to take a little bit more time in the Artisan interface, which becomes easier when you have things that do have more vertices. So now I'm just going and getting these all to be locked down, and then hit play, and we can see now we have things behaving accordingly. So now you've sort of seen the basics of working with your goals. And for this balloon, I'm going to go in component mode and get things kind of back to the initial behavior that we had, where we had the bottom being values of 1. And so I'm going to grab all of those and put those to a value of 1. And then these at 0.9. These at 0.8. These at 0.7. And then the top at 0.6. And with that done, now we need to move on to take a look at how we can get this balloon to be emitted. So now we can see the balloon's behaving softly. Our goal weight is at 1. Let's actually put it to, let's say, 0.8, just so we can get the whole effect to be a little softer. And now how can we get a balloon or a soft body to be emitted? Well, the thing is that these particles I've mentioned are normal particles, which means that they have a lifespan. If I go to the attribute editor for the balloon, and in here we go to the lifespan folder, you'll see that the lifespan is set to live forever. Well, what would happen if we set the lifespan to 1 second? If I go in here and I hit play, we're going to see this. Notice that the balloon seems to be flickering or flashing. That's because every second the particles of the soft body are dying and then immediately being reborn. That's happening because the particle object for the soft body has an attribute in here in the soft body attributes folder, which is called enforce count from history. What that basically does is it, for the soft body, checks to see if the original geometry is still there and what the original geometry is doing. And if the original geometry's vertices change in any way, the particles would update. So that if you increase the number of vertices on the original balloon, then the soft balloon would have more particles be created. But also what this means is that if you have your particles die, they'll automatically be reborn because it's trying to make sure that the soft balloon has the same number of vertices and points as the original balloon. But you can actually turn that behavior off. If I turn off enforce count from history, what's going to happen is those particles will actually die when they hit an age of 1 second. And so what we're going to do in here is let's delete the animation that we put on the original balloon, so that now we have no movement at all. But we do have our particles dying when they reach 30 frames old, or 1 second, because we're working at 30 frames per second right now. Then what I can do is select the particles at, let's say, frame 60, after they've already died, select the particle object in the outliner, and save initial state on it. If I save initial state on the particle object at this point, and I go back to frame 1, my balloon is gone. So basically I killed off the particles of the balloon and saved initial state. But what we can now do is connect this particle object that has no particles in it anymore to an emitter and actually emit that soft body into view. So this means we need to create an emitter. And that's simple. Let's just create an omni emitter. So particles, create emitter. I'll hit reset, hit create. And by default, what's going to happen is I'm just going to get a regular emitter, which is just emitting these particles into the scene. So it created a new particle object for this new emitter. Well, we don't need that particle object. So I'm going to delete the particle object that was created with the emitter and just keep the actual emitter. Then what we're going to do is connect the particle object for our soft balloon to that emitter by going to the Dynamic Relationships window. So Window, Relationship Editors, Dynamic Relationships. I'm going to click on the particle object for the soft balloon, go to the emitter mode, and then click on emitter 1. And automatically by doing that, if I hit play, there you go. And so in here we're going to see what's happening. But at this point, our particles are still dying every 30 frames. So you now want to select the particles for your soft balloon and set their lifespan back to live forever so that those particles never die once they're born. And now when we hit play, we'll get this. That balloon is just emitted into view from this emitter. So if I move the emitter all the way over here and hit play, we can see how it happens. So I'm just moving the emitter around and we can see how we're changing where that balloon is being emitted from. And so it's pretty cool being able to emit soft bodies into view this way. Just be aware that that emitter is constantly emitting particles even after the original particles for the balloon have been created. So if I take those particles and switch them into sphere mode, we're going to see this. Notice that particles are continuing to come out of the emitter. So what you'll want to do is just keyframe the rate of the emitter so that it turns off once your balloon has been created. And so if we get our little rig back, we can see at what point do we need that emitter to turn on. So I'm just going to turn it off for a second, hit play. And so it's pretty much around frame 70. I can scrub in here, or someplace around frame 65 to frame 70 that we want that emitter to turn on. So 65, let's say. So let's grab the emitter, let's move it to the end of this hose, like so, and then let's keyframe it with stepped keys so that it's off at frame 1, and then at frame 65, let's give it a rate of 100, keyframe it, and now let's hit play and see what happens. And let's go back inside here. And there you go. So maybe we want the rate to be a little higher at frame 65. So let's put the rate to like 500, just so that balloon pops into view, and hit play. And there we go. And then we can see we're getting all these additional particles that are being emitted out of that emitter. And so let's say at frame 75, we'll turn off the emitter key so that we just get the emitter to pop on. And then we've got the balloon. And then as far as these particles, we really don't even need to see them. So let's switch those to a point mode so that they wouldn't render. Then we can see in here there's a little bit of an offset there. So let's grab the emitter. And we can just scoot that to the side a little bit. And then hit play. So you can see it really was not that difficult to recreate this balloon effect with the balloon being emitted. And if we want the balloon to be emitted slower, you lower the rate on the emitter. If you want the balloon to be a little bit more jiggly, we could go and lower the goal weight. Let's put the goal weight to 0.4, and if we hit play, we're going to see it have much more of this result. And right now, all of the particles have similar goal. We have higher goal at the top than the bottom. You might want to change that, obviously, to fine-tune the effect. But the point should be clear right now with the basics of soft bodies. We're going to look at a bunch of other examples, but I just want you to understand that with soft bodies, we are replacing vertices with particles. Those particles are normal particles. They can have lifespan. They can render if you want. They can be connected to fields and so forth. And then also in here, be aware that anything that the original geometry does, the soft one is going to follow. So we saw how we animated earlier the original balloon rotating 90 degrees and rotating back, and that created a result. If my original balloon had a blend shape on it, that also would then be carried over to the soft body. But we'll look at examples like that a little later on. So this is our first little exercise we wanted to do with soft bodies. So now what we're going to do is look at another example where we're going to use particles with soft bodies with goals, but this time we're going to move on and we're going to create a curtain. And so that basically a curtain hanging from a curtain rod. So let's go in and get that scene loaded up. Okay, so now to move on to the curtain. If I play this little movie file, we can see that we have a soft body NURBS piece of geometry that was just created by lofting a couple curves together, and that we're getting nice behavior that is definitely looking like a piece of fabric that's hanging on the curtain rod, and also we've been able to get the curtain to get pulled open, and the rings are moving with the curtain as it's sliding along the curtain rod. So we're basically going to take a look at how to put something like this together using soft bodies. And so I have the scene open inside here, and we can see that first of all, with dynamics, you have to always remember that in your animation preferences, you set your playback speed to play every frame, just because the dynamics builds upon itself. And so if you set it to real time, you're going to get a different calculation that's not going to be accurate. And so it's set to play every frame, which means that you can't scrub. And so first of all, you'll notice that in this scene, I am able to scrub, and that's because I've cached the particles. And once we put this back together again, we'll do that so we can see the benefit, just so that you can scrub as you're taking a look at the simulation. It'll also make things play back faster. And so at this point, we can see the behavior that we're getting. We can see that we do have the rings inside here for the curtain. And so to take this apart, what we're going to do is let's just sort of hide the walls. And for this geometry inside here, I'm going to delete the soft body. And so as we had with the balloon, we can see that we have our soft body geometry, which has particles right there. And then also we have our original geometry, which is hidden right now. So I'm just going to go in and delete the soft body and delete the fields that are inside the scene. And so that what we're going to be left with is our original surface. And so if I go right now with the original surface and hit play, this is the animation that's on the original geometry. And so the original geometry is simply non-proportionally scaling. And then the rings that we have up here are constrained to that geometry. And so in Maya, if you're in animation mode, there is a constraint called the geometry constraint. But the problem is that it doesn't keep things constrained to a UV coordinate. And so what I've actually done in here is I've used what's a script that you can get at high end, which is called Rivet. And so you'll notice that I have these little green locators that are inside here, and my rings are actually constrained to the locator, and the locators are constrained to the surface via the rivet constraint. And so basically what it allows me to do is I can go and right click on the surface, place what's called a surface point, which is just a default Maya feature. And so let's go in here and you can see I'm just placing this little yellow dot. And then once I've positioned it, I can just execute the rivet script. So by just typing rivet, once that script has been sourced. And we can see that I get a little locator on that surface. But what you'll notice about the locator is if I now scrub through the time slider again, you'll notice that that locator is moving with the surface. And so this is a UV constraint. And so it's very handy for a variety of things. But for what we're doing in here, as far as getting these rings to stay constrained to the soft body, it's going to be important. And also you could use this to place buttons on a shirt, for example, and things like that. But in this case, I actually have the rings constrained to the original geometry because in the top part of the cloth, the soft body is going to stay completely locked on to the original geometry using high goal weights. And so it's okay to have the rivets constrained to the original geometry as opposed to the soft body. And so now that we've got the soft body gone and we just have our geometry, and again, this was just created by making a loft, so that I just went to the Create CV Curve tool, created a curve that was a little bit wavy, like so, and then duplicated it, selected to two curves, and in modeling mode, created a loft, like so. And then I rebuilt the loft using the Rebuild Surface tool so that there's enough vertices there so that when we turn it into a soft body, we can get a good amount of deformation as far as the type of creasing and pleating that we're going to end up with. If you don't have enough vertices, like I mentioned with the balloon, you're going to end up with problems. And so what we're doing inside here is you'll notice if we look at the original geometry for the curtain, if I look at it from the front view, and let me just hide the grid, we can see that if I go into the attribute editor, it has 30 spans in U and 35 spans in V. And I've done that so that we're getting what is basically squares everywhere along here as far as the spans. I do have some spans that are a little bit more rectangular on the sides, but you want to try and keep things as square as possible. And the reason behind that is just that by having them square, it's going to create a more even surface tension on the soft body. So now that we've got our original geometry, what I'm first going to do is I'm just going to delete the animation that's on this geometry, because we'll set it up again later on, so that now when I hit play there's nothing. So I have no animation in the scene, I just have this NURBS object. And what we're going to do is we're now going to select it, we're going to go into dynamics mode, and I'm going to go and turn this into a soft body. So when I turn it into a soft body, go to Soft Rigid Bodies, Create Soft Body, and in the options, I'm going to hit reset. And what we need to use for this result, or for this effect rather, with the curtain, is we want to use duplicate, make, copy, soft. And the reason is because when you have something like a curtain, you want to use goals on part of the geometry, but not on the entire geometry. But since we do need to use goals a little bit, we need to use one of the duplicate options, and then I'll check on hide non-soft object, make non-soft a goal. Because basically when you have a curtain, you want it to be able to hang with gravity, you want it to be able to get blown by the wind. And with those kind of effects, what you're going to want is you're going to want most of the curtain to just hang, but then the top part of the curtain needs to be sort of constrained to where the rings are that are keeping it on the curtain rod. And that's why we're using goals, is so that the top part of the soft body is going to stay pretty much locked on to the top part of our original target geometry. But the rest of it will have low goals. So now I'm going to hit create. And in here, now that I've done that, actually, before I hit create, what I need to make sure I do is I need to turn off my cache. I have the cache on from before, and again, we're going to make one of these caches later. It's just the cache is accessed by going to Solvers, Edit Oversampling, or Cache Settings. And we're going to go to this window a few times, but for now, I'm just going to turn my cache off. And then now I'll take my geometry and turn it into a soft body. And so now I can see that I get my particles, and if I open up the outliner, we can see that I've got my original geometry, which is now hidden. So if I move it, we're seeing those rings move, but we're not actually seeing the curtain geometry. And if I grab the copy, we can see that it has particles. So at this point, if I grab this curtain, the first thing we know we're going to want on this thing is some gravity. So I'm just going to select the particles and add a gravity field. By doing that, when I hit play, what you're going to notice is that this soft body is just going to fall a little bit and then rise back up. If I make the gravity field stronger, let's just increase the magnitude to, let's say, 100 and hit play, you'll notice that it's going to fall but then move back up. That's because the goal weight of 0.5 is balancing with the gravity field and then coming to an equilibrium as it's getting dragged down. And so what we clearly need to do is we don't want the top part of the curtain to fall with gravity, so the goal weights need to be higher. But the bottom part of the curtain should fall with gravity. So since we know that we need varying goals on different parts of this soft body, we know that that means we're going to need to use goal PP. And so I'm going to go in here for my soft body, select the particle node, and I'm going to set the goal weight to a value of 1. By doing this, if I now rewind and hit play, the curtain is not going to fall at all. But now what we want to do is set our per particle goals. Now if I go in here and I can either use Artisan or the component editor. So let's say we use Artisan. So I'm going to go to the attribute paint tool for my soft body. We can see that it turns white because all of the particles have a goal PP of 1. I will now go in here and flood the whole thing with a value of 0 and then make the value 1 so that I'll paint with white, and I'll just go up here on the top part of my soft body and I'm just going to give the top couple hulls a value of 1. And so now you don't have to be perfectly dead on with this, we just want to make sure that we get the top to definitely be white, and then I might go and make it black again with a smaller brush, just so that I'm really only doing the top 2 hulls. So I'm just cleaning this up with Artisan. So Artisan just can be a lot more intuitive than using the component editor, but you still want to take your time. So now I've got my goals edited, and what I've done in here is I've got a value of 1 along the top edge, but a value of 0 in the entire bottom region. The reason I'm setting it to 0 is because if you set it at anything other than 0, your curtain is always going to return to this rigid square shape. But with something like cloth, whether it's a curtain or a cape on a character or clothing, there's the issue of the fact that you want it to just hang and come to rest naturally based on collisions and fields. And if you have a goal weight anything other than 0, it's going to always return to this rigid square shape. So this is the case where goals actually are going to make more sense if they're off. Because even with a low value of 0.1, what's going to happen is, let's say I do set everything to 0.1. So I say add a value of 0.1 to the entire thing, flood. What we're going to see with this is if I now go in and hit play, you'll notice that the geometry is going to fall with gravity, but let's get the gravity field to have a more normal magnitude. And it's going to fall, and then eventually it's going to just come to an equilibrium. It's going to rise back up and then fall again. Also, what we're going to notice inside here is that we're not getting equal stretching on the geometry. That's just because the goal weights were not edited to be exactly the same all along that top edge. If you want it to be more even, you may end up wanting to use the component editor. So the thing is, we are going to get this sort of soft behavior, but let's say I go and I grab my curtain rod and my original geometry. So let me just grab those surfaces, group them together, and animate this moving forward a little bit. When I hit play with this, the result we're going to get is not really going to look like a piece of fabric, because the entire bottom part of the cloth all has the exact same goal weight, and so it's going to move forward as this solid, rigid object, as we can see inside here. So it's not really looking like fabric. So this is why we want to not necessarily go in and set the goal weights to all be the same, but if I go in and set the goal weights manually so the top edge is 1, and then I gradually, like with the balloon, lower the goal weights as we get down towards the bottom, it's going to be very, very tedious to enter those goal weights, and it's still going to end up coming to equilibrium in a in an unnatural state for fabric. So let's go in here, and let's just be a little bit more precise and use the component editor. So I'm going to go into component mode. I'm going to grab all of the particles. In the component editor, I'm going to set the goal PP to a value of 0 for all of them. And then in here, I'm going to grab the ones along the top edge, just going about 3 hulls in. And so this is something that, it's going to maybe be easier to just hide the geometry, so I'm just looking at the particles. So I just turned off the display of NURB surfaces. It makes it a little bit easier to see the particles. And so I'm selecting the top 3 particles along the entire surface. So for a straight object like this, it's just going to give you a little bit cleaner of a result. So I've now got the top 3 particles selected along the entire thing, and for those I'll give them a goal weight, goal PP, of a value of 1. Close this, and then now let's get our geometry back. And if I now hit play from the side view, or let's say from the front view, we're going to see this. That the top edge is going to move with the original geometry, but the rest of our soft body is just going to fall forever. So you can see it's just going to fall down, because the goal PP is at 0. Well, let's now go and delete the animation that we put on our original geometry, so that we just now see it fall, like this. And now what we're going to introduce is I'm going to select my particles, and I'm going to create springs. Now, springs are something that are going to be used very often with soft bodies. Springs allow you to create ripples, basically. They allow you to have the motion of one particle pull the particle next to it, which then pulls the particle next to it. You're basically connecting all of your particles to each other with springs. And if you think of what a spring is in the real world, whether it's a spring that you have like a coil spring in a car, or whether you're talking about a slinky, any kind of, or a spring that you have in a pen, you'll find that any spring, if you let go of it, has a default rest length that it always tries to return to. And if you take a spring and you compress it and let go, it always returns to that rest length. If you stretch it, it returns to a rest length. And so it's the same idea of what we're going to create inside here, it's just we're going to create a lot of them. So if I go to the creation dialog box and hit reset, the default creation method that you will see in here says min-max. This allows you to create springs based on distance. But when you're dealing with soft bodies, you'll usually want to use the creation method called wireframe with a walk length of 2. That basically means that if we were looking at, let's say, the particle right here in this corner, if we have a walk length of 1, that particle would be connected to this particle and this particle with a spring. And then this particle would be connected to this particle, and this particle with a spring. If we put a wireframe walk length of 2, then particles are connected to the ones that are directly adjacent and the ones that are diagonally adjacent. And so we're going to use that option. So if I go and just make this window a little bit easier for you to see. And so in here we can see, let's actually expand that and zoom in. So again, creation method wireframe with a walk length of 2. And this is just going to create our spring so that we'll get a little X in all of our spans. And then underneath that, you'll see we have spring attributes. But all of this stuff can be changed later after you've created the spring node. So we'll talk about that in a second. And so let's just jump back to Maya now, and let's create the springs. With them created, what we will see if we go into wireframe mode and I select the springs, is we basically have these X's all over the place. And so these X's have been created where those are individual springs. And so we have these individual springs all over the place. And one thing that you will find is once you've created springs, they're very visually distracting. They get in your way of seeing your geometry. And so it's very common to just take your springs and hide them, because they'll still calculate if they're hidden. And so now with the springs connected or created, let's now hit play and see what happens. And you will notice that what's going on is the geometry is now stretching. It's going to be very, very stretchy though. It's going to fall very, very far down because the spring stiffness is at a value of 1. It's a very low stiffness. So when you've created springs, the two main attributes you're going to edit are stiffness and damping. If you think of a regular spring like a slinky or whatever, stiffness is how quickly it tries to return to its rest length. So the higher the stiffness, the quicker it's going to return to the rest length. And the rest length with these springs is based on the default length that they have when they were created. And so the distance between your particles determines the length of the spring, and then that becomes the length it'll always try to return to. And so stiffness is very important. And then damping is how quickly the springs lose energy, so that it determines how much oscillation you get, or how jiggly of a behavior you get. So let's take the stiffness and put it to a value of 50. It was at a value at 1. And now I'll hit play. And now you'll notice we're getting something that looks a lot more like cloth. It's just very stretchy as far as the geometry. And so you just have to think what kind of material you're trying to make. And so let's now grab the springs and put the stiffness to a value of 150 and hit play. So depending on the material you're trying to create, you can see that you're just going to have to find the right stiffness. And what's going to happen is that your soft body is going to stretch, and then eventually it'll come to rest. Let me just increase my time slider range. So right now we're at frame 200. Now we're almost at frame 250. So it's going to take a long time for this to lose energy and settle. And so there's a couple ways you can deal with that. But first you have to decide on the right stiffness. Now you have to be careful of not putting the stiffness too high. Right now it's at 150. Let's say we put it to 300 and hit play. We'll notice that things are still working, and now we have stiffer behavior, which may be what you want. But if you go too high, let's say we now put it to 600, eventually your soft body is going to explode, like that. If that happens, but you're pretty sure that the stiffness that you entered is what you want, let's see if it does it with a stiffness of 500. Yeah. Let's see if it does it with a stiffness of 400. It does. And so if stiffness of 400 is what we want, we'd go to the oversampling. So you'd go to solvers, edit oversampling. And in this window, you'll see that one of the folders we have is just called oversampling, and you can specify a number. The default number has a value of 1. Well, I'm going to enter a value of 2. You would just increase the oversamplings by a value of 1 until your soft body stops exploding. But this will slow down your performance. But if this is what you need, then this is what you need. So with an oversampling of 2, if I hit play, what we will see is the soft body is a lot stiffer, and it's also not exploding anymore. But for the effect that we're doing, we don't need this soft body to be quite so stiff. So let's lower the stiffness on our springs back down to about, let's say, 200. And let's return the oversampling to a value of 1. Close, and hit play. So the next issue in here is that we have our soft body. It's falling to come to an equilibrium. But you may want to speed the equilibrium up. Or maybe you'll want to get it so that at frame 1, it's already in its equilibrium state. Now for that, there's a couple things you can do. One is you can increase the damping on your soft body. Just be aware that damping is another one of those attributes, though, that while it will cause it to lose energy faster, if you set your damping too high, you may again need to increase your oversampling. So let's take the damping and put it to a value of 1 and hit play. And so it's still going to end up taking a while. You'll notice that even with a damping of 1, it's going to be very bouncy. And so as we play, we're already at frame 200. If I put the damping to a value of 5 and hit play, chances are it might cause the geometry to explode. And so we therefore would increase the oversampling and then try it again with our higher damping. And so it's still going to be relatively bouncy, but what you'll notice is that when it goes on its bounce up, it won't go quite as high as it did before. It's pretty close though, so that's why I mean that this is a way of dealing with the equilibrium issue that's going to take a while. And so what I'm going to do instead is I'm going to leave the damping as the default value, but for my particles, I'm going to lower the conserve momentum attribute to a value of, let's say, 0.9 and hit play. When I do that, you'll notice that my particle object is now moving a lot slower, because when you lower your conserve, your particles are losing energy. And so what this means is that I can just, let's say, increase the conserve, let's say, to 0.95, so it's still relatively high, or maybe even 0.99. A very small change in conserve creates a very big change on the way your particles behave. So now you'll notice that it's hanging with gravity, but you'll notice that when it bounces back up, it's only going about 50% as high as it was before. So it's going to come to equilibrium probably by around frame 300. And so at this point, we're at frame 200. It's almost at its equilibrium state. So I'll let it go to about frame 300, and then what I'll do is I'll save initial state on my particle object. So I'll grab the particle object and go to Solvers, Initial State, Set for Selected. So that now when I rewind and go back to frame 1, my cloth object is now kind of settled in its stretched state. And so what I could do at this point is take my particle object and put the conserve back to a value of 1. Or you could leave it at 0.99 if you want this object to be able to lose some energy. So now that we have this behavior, let's see what would happen if we went back, grabbed our group node, which has the original geometry and the curtain rod, and set keyframes on them again, so that the original geometry, let's say, moves forward a little bit over, let's say, 70 frames, or let's say over about 80 frames, it starts to move forward. When we hit play, and also inside here, I'm going to set my oversampling to a value of 1 to speed things up. And we can see that the motion is traveling, let's look at this from the side view, through the soft body. And so we can see that maybe we'll get that original object to move a little faster. So maybe it moves forward in about 50 frames. Let's go back to frame 1 and hit play. So the springs are causing a ripple effect where the top part, which has a very high stiffness, is then causing the effect to move through the entire soft body. And so now we're getting something that definitely has the appearance of cloth or fabric. And so while we can use this to create something like this curtain, you can see that if we take a look at it from this higher angle, you'll notice that this is something that also can start to look like water. And we're going to do an effect like that a little bit later on. And so for now, we can see that our soft body is working. Let's also take a look at a couple other things. I'm going to delete the animation on the original object. And let's say we wanted to have a collision object in here. If you're familiar with particles and how they collide with the geometry, it's the same thing. I would just go and create, let's say, a piece of geometry for them to collide with. So let's say I create some large sphere. And I'm going to take that sphere. I'm going to delete history on it. And then I'm going to go to Particles, Make, Collide. And in the option box, we have resilience and friction. Resilience is how much the particles are going to bounce off that object. Now, something like cloth is not very bouncy, so I'll put the resilience to 0. Then we have friction. We'll probably want a little bit of friction, so I'll put the friction to about, let's say, about 0.1, 0.2. We don't want the particles to stick onto the sphere too much. And so I'll hit Create. And so now for my sphere, we'll see that it has a geoconnector node, which means that it is a collision object. And now I can go to the Dynamic Relationships Editor, under Window, Relationship Editors, Dynamic Relationships, select the particles of the soft body, go to the collision mode, and click on the sphere. And so at this point, I can take my sphere, and let's just keyframe it moving forward through our soft body. So let's say it moves forward through there. And let's say it takes about 100 frames for it to do that. And now if we hit play, we'll see that our soft body is colliding with that sphere. Now notice it's going to bounce very far back though. And this is now bringing up one of the issues with soft bodies, which is a limitation of the soft body engine versus the cloth module in Maya, where you'll notice that we're getting very nice behavior, but the thing is that when the particle comes up to about this point, you'll notice that it's colliding with itself. Well, in Maya, you cannot do particle-particle collisions. And because of that, that's a limitation of soft bodies where they're not going to collide with themselves. While the cloth module does allow you to create that kind of behavior. It's just, if you don't have access to the cloth module, you can't use it for whatever reason, you're going to see that soft bodies are going to work very well. It's just they work better when the amount of motion you want in the soft body is subtle. So that if you have a character that's just wearing clothing and the character's walking around, or you just have a curtain that's hanging in the wind or gradually moving, it's going to work very well. But when you have cases where your fabric needs to move very, very fast and quickly or in response to a fast-moving object, this situation, for example, or a situation where you have a character that's wearing a long dress, those are cases where you might want to use cloth. Because otherwise, what you need to do in here is you start to have to create extra collision objects in the scene to sort of act as the self-collision for your particle object. So in here you'll see if I grabbed my sphere and got it to move a lot slower through our soft body, then the effect is going to look a lot more natural. So you just have to sort of weigh what you're trying to do. Also, what you can do to mellow or calm down the soft body while it's reacting to something like this is to lower the conserve. Because remember, we put the conserve back to a value of 1, which is going to make the soft body very bouncy. But at this point, you can see by slowing down the sphere, now we're going to get a result that's actually working a lot better, and we're not actually getting any of the collisions inside here. And so you just have to be careful on how you animate your scene. So at this point, if we wanted to see what this looked like in real time, what we'd want to do is we'd have to do a play blast. Or we could cache the particles. If we're going to do a play blast, I'll just go and right-click in here. And let's just do a regular play blast and let this buffer in. And so again, we have a piece of geometry that was turned into a soft body using the duplicate make copy soft option. Then the original object is sitting inside there, static. We allowed the soft body to come to rest, come to equilibrium, and hang with gravity. We then saved initial state on it. We got it to hang with gravity and come to rest faster by lowering the conserve on the particle object. And then once we saved initial state, you can increase the conserve again. And at this point, we can see that we just have a collision object that's moving through here. And since we're dealing with dynamics, if we want to see this in real time as we're testing the timing of the effect that we're creating, we have no choice but to cache the particles or to do a play blast. And so you'll find that with dynamics in general, you're going to be doing a lot of play blasts. And also you'll notice that I have my frame rate visible right here, where it says 3.64 frames per second. That's very handy with dynamics, so that you have an idea of what the relationship of the playback speed that you're seeing versus what it's actually going to play back like in real time. And so I tend to always have my frame rate visible, which is accessible via display, heads-up display, frame rate. So it's now buffered in over 250 frames, and so let's go and hit escape so that we can take a look at what it is that we've just play blasted. And so I'm using F-check to play blast, and so it's just going to load all those frames in. And when you're using F-check, make sure you have enough RAM for the amount of frames that you are buffering into memory. I have about a gig of RAM on this machine, so I know I can buffer in, about 500 frames to 800 frames without a problem. So you can see when we play in real time that we're getting very nice behavior. It's definitely getting the feeling of being a stretchy type of cloth or fabric or material. And as we scrub through this, then we can get an idea of whether or not we'd want this to play back faster, slower, or if we want the material to be more stretchy, less stretchy, if we want to lower the friction on the sphere, because you can see the friction is adding to the bounce back that we get on this soft body. So another thing that we could go and do inside here is, now that we've seen that collisions are working, is let's go and get the curtain to open. For something like that, we can go in and take our original object, which is inside here, and we can scale it. And you can see I've moved the pivot point of our original object to the side. So that right now if I hit play, we don't have anything. But now let's go and take the original object. Let's set a keyframe on its scale at frame 1. And then let's just keyframe it scaling. But we might want to see the soft body, or the original object rather, when we're doing this. So what I'm going to do is I'm going to hide the soft body and then get my original geometry to be displayed again, so that I can go in here, scale it, and then go in and set another key. So let's say that for it to open it takes a couple seconds. Let's keyframe the scale, so that now if I hit play I can see the animation. I can also scrub, because we're not looking at dynamics right now, so I can get an idea of how fast that thing's going to open. And then we can hide the original geometry, display, hide selection, and then get our soft body to be visible again. And now if we hit play, we'll see we're getting this result. So again, we can see our original geometry is allowed to scale, it's allowed to move, it could have any deformations on it or whatnot, and we can see that this nice result that we're getting inside here with our curtain opening. And by creating a little bit of a waviness in our geometry, it's caused us to be able to get some pleating in the geometry as the curtain opens. And so at this point we could even get our walls back. I just turned their layer on, and then we could go in and decide to do a cache. And also be aware in here that we may need to have another collision object, because you might want the curtain to collide with this wall. And so for this wall, I'd have to go in and give it a geoconnector node. And so we'd select the geometry. You can see it's just a big poly object. And we'd say make collide. I'll lower the friction down. And then go to the dynamic relationships editor. Click on the particles of the soft body, collisions, poly plane shape, because I created this by extruding faces off of a plane. So now our curtain won't go through the wall or through the floor when we play this back. So it will slow performance down a little bit, because now it's having to look out for all of those collisions. Another thing that you can do also to try and lower down the amount of self-collisions that you're getting is get the particles of your soft bodies to actually be emitters of, let's say, a radial field, so that each particle in the soft body is a radial field. And if you do that, you can go and increase how those particles try and keep away from each other. And so that would be a matter of just selecting the particles and creating a radial field. And then select the radial field, shift select the particles of the soft body, and go to Fields, Use Selected as Source of Field. So that now the actual particles of the soft body are emitting a radial field. I could then turn on Apply Per Vertex, lower the max distance to about 1 unit, and increase the magnitude a little bit. And so that now my soft body, each of the particles are pushing away from each other, and it's just going to reduce again the self-collisions that we're getting. And so if we now wanted to go and take a look at this, or we wanted it to be a little bit more interactive as we're testing, we might want to cache. And for caching this type of particle effect, we're going to go and first have to save the scene. And so I'm going to say save scene as, we'll just call this curtain test. Save it. And once you've saved the scene, we can then set our time slider to the range that we're interested in caching. So let's say we want to cache 210 frames. I'll set my time slider to 1 to 210, and then I'll go to Solvers, Create Particle Disk Cache. Go to the options, and then in here you will see that it's going to specify a cache directory. What Maya is going to do is, in the particles directory of the current project that you're using, it'll create a directory using the scene name of the file that you're working on, and then it'll put the cache data in there. And make sure that you send your cache to a local drive, because caches can get very big. You can easily end up with a cache that's several gigabytes in size. And so it's good to have a local drive that's very fast that has several gigs available for your cache information. You really don't want your cache to be sent over a network. And so at this point, we can also change the cache directory if we want. So I could say curtain test, whatever you want, and then hit create. And when I do that, it's giving me a warning saying that the directory name that I specified is different than the scene name. And that doesn't matter, so I can say that's okay. And now we can see it's caching. So if I look at the time slider, we can see it's at frame 14 now. Now it's at frame 20. It doesn't play back the animation in your perspective view while it's caching the animation. And so right now it's at frame 40. So it takes a while to cache, but it's really a good idea with Maya to cache things. If you want to scrub, you have to. And also before I render, I tend to cache my particle effects out. It tends to increase the reliability and the stability of the renders you get as far as making sure that they are locked on to the way things looked in Maya. It's just a little bit of a quirk with Maya that you need to do that, but I tend to take the time in the disk space to keep things predictable. And so it might take, a minute to 10 minutes to 20 minutes to create the cache, but that's just some extra time that's worthwhile. So you can cancel the cache at any point by hitting escape, and it'll just have the cache data to that point. And you'll find that things will still work well. But it also, sometimes, if you don't let it complete the cache all the way up to the right frame that you specified on your time slider, there are times that it can get a little bit quirky. So it is a good idea to just let it finish. And so right now it's at frame 180, so it's really not taking that long. And so we'll just give it an extra few frames. And then what we'll be able to do is scrub and see if we're happy with the time sliding or the time slider performance, and also it'll make your play blasts go a little bit faster. So now at frame 210 we can see the look that we have, and now you can notice that we can scrub. And so now it's going to make it much more intuitive to analyze the overall behavior that we're getting in here, and also to locate the frames where we're getting collisions. If I go in here and I hit play, we'll notice that the performance we're getting right now in shaded mode is about 9 frames per second, which is pretty good because it's coming off of the cache. So I can even turn textures or lights on, and now I'm actually getting about 12 frames per second. And so what we're going to do in here is that we're just going to scrub. Everything looks very good, but if I go to about this frame right here, around frame 130, I can see there's a little bit of a collision inside there. And so what you might want to do is create a piece of geometry inside there that you're just sort of creating as a little blocking object to guide your soft body. But the thing is, very often with soft body effects, you're just going to determine what you can get away with whenever you're working on a shot. If this is a soft body effect that's going to be in the background, sometimes you can get away with things like that as far as that collision. If this soft body effect that you're doing is really a foreground effect that's one of the main characters of the shot, then that's when you're going to spend more time to finesse the effect and solve some of those little quirks. So while we wouldn't get this kind of stuff with using the cloth module as far as the collisions, there's also a lot more flexibility with soft bodies because you can use anything that you know about particles. All of your fields will work correctly. Since we have Goal PP, we can actually write creation rules, runtime rules, and so forth. A lot more control than you have with the cloth module. There's just a little bit more work to avoid those collisions. So at this point, we've pretty much done with the curtain effect. And so now what we're going to do is move on to something that's similar, just to validate a lot of the concepts that we just used. We're going to now create a tablecloth. And so let's now move on to that effect. So here we have a scene where there's a tablecloth which has been draped over this table, which is also blowing in the wind. We can see that we're just getting this subtle gradual blowing that's coming from an airfield, which is just turning on and turning off to create this gradual behavior. And so for something like this, we are again using soft bodies. And so to create a tablecloth, what you're going to end up wanting to do is you're going to be again using goals as well as springs in a similar way to what we did with the curtain. So if I go in and hide our soft body, I'm going to get the original geometry to be displayed. And so we can see that it was simply a NURBS plane. And for this NURBS plane, we can see that it has a good number of divisions in it. And if I go into the attribute editor, we can see it's about 30 and 30. And for it, actually, it would be a little bit better if we had more of a square pattern inside here. So what I'm going to do is I'm going to go into modeling mode and go to rebuild surfaces and rebuild this surface. So let's say maybe it has 40 and 30 spans. And so now we're getting more of a square shape. And so again, that's just trying to keep the tension to be even across the entire surface. And once that's been done, I can delete history. And now we're ready to turn this into a soft body. So I'm going to go into dynamics mode. I'm going to create soft body, duplicate, make copy soft. I'll put the weight to a value of 1 and hit create. And when I do that, I then can see that I have my particles that are inside here. And for this soft body, let's just go into wireframe on shaded so it's a little bit easier to see what we have in the scene. And let's take the particles and also connect them to a gravity field. And so in here, I'm going to select the particles, connect them to a gravity field. So now when I hit play, we shouldn't expect anything to happen, basically because the goal weight is at a value of 1. But now we want to go in and edit the goal PP. Now, obviously for something like a tablecloth, we want the ends to be able to drape over and hang. And that means we definitely do not want the goal PP to have anything other than a value of 0 for the region of the tablecloth that needs to hang. Because if it has a goal weight even of 0.1, eventually that tablecloth will straighten itself out. And so clearly we don't want that. So we need to go in here and edit our goal PP. So for this, it's going to be easiest done by just jumping into the top view, going into component mode, and selecting the particles. So we know that our particles already have a goal PP of 1. So I'm going to select all the ones on the edges that I want to have a lower goal weight. And so inside here, I'm just going to go and grab my particles just along the edge. So I'm going to go further enough or far enough into this so that I can have enough geometry to hang over. So we can see I'm going the equivalent of about 4 spans in. And so now let's just go and shift control drag, grab another 4 spans from this side, and another 4 spans or so from this side. And so 1, 2, 3, 4. And we can see that we now have a bunch of particles selected. They're very hard to see when they're selected. You could just change the display type to spheres. Although we can see that the default radius for spheres is very big. So again, to make it easier, I could go into the attribute editor and edit the radius. Let's say it's like 0.01. So that now the particles are a little bit easier to see. And so at this point, it's clear what particles I have selected. And so now we can just put them back into point mode and go to the component editor, go to the goal PP, and enter a value of 0. So that now what's going to happen is let's select the soft body, increase the display res a little bit, and if we hit play, we're going to get this. We're going to see, and we could maybe hide the ground for a second, so let's select the ground surface, add it to this layer that I just created, hide that layer, so that when I hit play, we just see this result. And so the part of the tablecloth that has a goal PP of 0 is just going to fall forever. So now clearly what we need is springs. So we select the particle object, or the soft body, and dynamics mode, create springs, and the options will hit reset, wireframe with a walk length of 2, and hit apply. When we do that, again we're going to see a little X pop up in each of the spans. Also, for performance reasons and also just to make things a little bit visually cleaner, let's select the spring node and hide it. But then we can still select it so that we can change the stiffness. But at this point, if I hit play, we're going to see it's going to be very, very stretchy. So it's going to fall for a very long period of time before it's going to bounce back up. And so what we're going to do is let's up that stiffness to a value of, let's say, let's try 150. Hit play. And now we can see we've got much better results. The only thing is that, again, it's very, very bouncy as far as the oscillation that we're getting. So if I put the stiffness down to 100, it's just going to make the material stretchier. It's going to fall a little bit further down towards the ground, but it's still going to be very bouncy. And so we need to decide how stretchy we want it to be. Maybe 150 was a good stiffness as far as how far down it stretched. But now to reduce the bounciness, again, either we can use the damping or the conserve. If I take the damping attribute and put it to a value of 2 and hit play, what we're going to see is it will lose energy a little bit faster, but also it might explode. So that didn't make much of a difference. Let's put the damping to 5 and hit play. And now it's exploding. So then we'd go in here, jump to edit oversampling, increase the oversampling to 2, and hit play. So again, this is just going to be something that you're going to have to go back and forth. You can see it's definitely not quite as bouncy as it was before. It still is bouncy. If we wanted to make it even more dramatic as far as how quickly it slows down, we could put the damping to 10. We just might have to increase the oversampling. But notice that it is eventually going to come to rest, as we can see inside here. Let's put the damping to 10, rewind, and hit play. And so now it's exploding, so we'd have to go back to the oversampling. But look how much easier it'll be as if we just leave the damping down to a low value of 1, let's say. So there is some damping. It should allow us to put the oversampling back to a value of 1 so that things play back faster. And then what we'll do is we'll grab the particles and put the conserve to, let's say, 0.95 and hit play. And now you'll notice that it's going to come to rest a lot faster. So it's really kind of the easier thing to do is to rely on the conserve attribute. And so now I've got it coming to rest. And so we're just going to wait until we're happy with how it's come to rest. And once we're happy with that, I'm just letting it play for a while. And then we'll grab the particles, save initial state. And then now I can grab the particles. If I go back to frame 1, we can see they'll stay in this position. We can go and get our floor back. If I want for my geometry inside here for the soft body, we could go and assign it a different shader, maybe give it a shader that looks a little bit more like fabric. So that now we have this kind of sort of cloth shader. And so now we have this object that I can, if I want to, go in and put the conserve back to a value of 1, so that it's going to be a little bit more bouncy. And there you go. So using goals PP, and springs, as well as changing the conserve and then saving initial state. But now we do have a dynamic particle object, meaning that if I wanted to go and take my particles and connect them to an airfield, we can see I already have an airfield in the scene that's sitting right over here. That's just directed to be pointing towards the tablecloth. So we can see it's pointing towards the tablecloth that way. And so let's just go and select the particles of the soft body and connect them to that airfield. And so that's just going to go, and we can see, get our soft body to get blown to the side a little bit. So now hopefully you're understanding what's going on as far as soft bodies, a lot of the major concepts, and now we can just sort of move on to a couple other examples that are all going to use a lot of related concepts, but my main goal is to try and get you to see how flexible the soft bodies can be as far as the range of applications that they have. And so the next thing we're going to take a look at is making a candle flame. So for a candle flame like this using soft bodies, the reason that this can be very successfully done with soft bodies is it has to do with the rendering issue, in the sense that you could do flames with just particle rendering using blobbies, but at the same time with geometry, the nice thing about it, and the reason I mentioned blobbies, is because you can then use more of a surface shading technique, because something like a candle flame, as we can see, if we look at this movie right here, we're getting a nice rendered result. But candle flames tend to render more using geometry type techniques as opposed to feathered cloud rendering techniques, because of the fact that if we go and let's just do a regular render in Maya, the result that we're getting with the movie is showing us that we're getting some flickering light because I put a point light inside there that's flickering. But we're getting nice rendering where if we have something like a candle flame, what we will notice about it is that if I just go and do a render, candle flames tend to have a very hard edge, but they have varying transparency. And so in here we can see when it renders, notice that it rendered the flame as a post-process, because the flame is actually a glow pass that is being calculated on the geometry. So that on your shaders in Maya, if I go and take a look at the shader that I have assigned to my candle flame, which is going to be this shader right here, you'll notice for it that I have a folder in here that's called special effects, and all of your shaders have this in Maya, Lambert, Blinn, whatever, and there's a checkbox called hide source. and then I have glow intensity, which I've turned on. So what I'm doing is I'm not rendering the geometry, which is what hide source means, but I am rendering the glow only. And then for the glow, what we'll also notice if we take a look at it is that just like with a candle flame, we have varying transparency, meaning that it's more transparent in the center than it is in the edge. Now, we don't have time to really get into a lot of the specifics of the rendering. There's actually a tutorial I wrote, which is available at the Gnomon Workshop website, that explains the rendering aspect to this as far as how to set up your shader and so forth. So that we can get this kind of look that with just, let's say, multi-point particles or cloud mode particles and so forth, or hardware rendered particles or even sprites, you would not really be able to get this kind of look, which is why I chose to do it with geometry. But then if you're going to use geometry, you need to get behavior like a candle flame, which you can do easily with Softbodies. And so taking a look at the scene file, what we'll see in here is that I have a piece of geometry that was simply made from just revolving a curve, which represents the candle flame. And then we'll notice that it's behaving in a softbody fashion. The flickering that I'm getting is just simply a point light. And so you can see that I have a little point light that's been positioned inside here. And so let me just go inside here for a second and just move in so that we can see that little point light. And so when I hit play and I look at the flickering light, it's really just that point light that I positioned inside there. And then I just wrote an expression on the intensity of the light to make it flicker, because particles can't illuminate your scene. And so you're going to need to do that by placing additional lights that you manually animate to move with the motion of your particles and to have their intensities flicker correctly. And so this is just a simple expression on the intensity of the light, where we're just going in and getting the intensity to change based on the absolute value of noise of time. And so if I go and just paste that into Notepad, just so you can see what the expression looks like, and we can actually go in and actually make the font a little larger, this is what I have on the intensity of the light. So it's just getting the light to flicker, because the noise of time is going to give you something that's going to go from -1 to 1. You don't want your light intensity to become negative, and so we do the absolute value of noise of time. That gives us something that goes from 0 to 1, and then by adding 0.6 to it, it gives us something that goes from 0.6 to 1.6, and that becomes the value range that our light's going to flicker with. And so inside here, aside from the light, we then have the softbody issue. But it's very easy to set up based on what we've already seen with the curtain and the tablecloth, where if I select my softbody geometry inside here, if we go and jump to the attribute paint tool, we can see what the values look like. And so we can see that I have a high goal PP at the bottom of the candle flame, and then the goal PP goes down as we get towards the top of the candle flame. So that when we go in here, let me just go and create a new camera, and let's take a look at it from a different point of view. And so again, let's go and grab the geometry, go to the attribute paint tool. When I go back to frame 1, at frame 1 it's just in the original position, and so this is what the geometry looked like that I made, the revolved surface that I did. And then when I hit play, you'll notice that the bottom of the candle flame is pretty much staying put because the goal PP is so high. And then towards the top is where we get the movement. But then what I'm doing is I'm using springs to keep everything together to create more of a rippling, fluid behavior. So that instead of having to go in and set goal PP on a per particle basis, pretty much what I did is the bottom has 1, the top has about 0.2, and I didn't really worry about feathering. There's a little bit of a gradation in there with the weights, but I really didn't do very much of it. Towards the top of the flame, it's all the same value as far as goal PP, and I'm really just relying on my springs to keep it together. And so for my spring object, we can see I have a stiffness of 150, so that it's stiff enough that the flame stays together. And then the color we're looking at right there is just the color that I have on the shader. So that's bluish towards the bottom, then becomes orange, and then red. But again, I'm not rendering the geometry, I'm just rendering the glow that's added to it. And so at this point we can see the result that we're getting. So if I took the stiffness on the springs, if I turn my springs off, we're going to get different behavior, because we're going to see it's just going to all get kind of ripped apart. And so by having my stiffness on with my springs, it creates a more natural fluid result. But I do have a little bit of goal PP so that the candle flame stays pretty much straight. If I go and take a look in here, as far as I've got my geometry, and if I get the original geometry, when we play, we can see that if I had a goal PP of 0 at the top of the candle flame, it wouldn't stay straight. It would move. It would just sort of go in any direction. And so that's why we need a little bit of goal PP. And let's go and hide the original flame. And then in here I also have a little radial field that we have in the upper right, which is just moving around. So you can see if I turn on its transform node, there is the radial field, and I just animated it with a couple expressions so that in kind of a noisy pattern that radial field moves around. If I go and deleted the expressions, you can see the expression that I have on the translate X, for example, on my radial field. We jump out here, is the radial field's translate X equals the sine of noise of time times 10. That's just creating a backwards and forwards type motion on it, just giving sort of noisy movement on the radial field. If I decided to just delete the expressions that I have on my radial field, we'll just go in and be able to manually move that radial field around. So if I moved it over here, the flame gets pushed to the right. If I move the radial field over to the right, the flame gets pushed to the left. And so I can just use my radial field to control how that flame gets pushed around. So again, a soft body example where we have a combination to finish the effect of geometry of soft body, springs, goal PP, and then some rendering using a sampler info node's facing ratio attribute. And again, for that, we can't really get into how to set that up, but just go to that tutorial at the Gnomon Workshop site, which is free to read, and that's something that explains the whole sampler info thing to get varying transparency. So that's pretty much it for the candle flame. Now let's go and take a look at another example where we use soft bodies to create a cape, so something similar to clothing. Now, for this cape example, if I play this back, we can see that the character is not being rendered, just the cape. And we can see that we are getting this nice dynamic result where the cape is sliding along the ground, it's trailing behind the character and reacting to the movement of the skeleton that's animated inside this scene. And so this is really going to be very similar to what we did with the curtain and what we did with the tablecloth. It's just now our original geometry, which is the goal for the cape, is parented to the skeleton. And so if we take a look at the scene out here, we can see that I have cached the particles so that I can go and scrub the scene. We can also see how that cape is colliding with the floor. And so the floor is a collision object. We can see that it has a geoconnector node on it, which tells us that it has been set to be a collision object for the particles of the soft body. And so let's just go and maybe keep that selected so we can see really how that cape is reacting to the movement. So if I go and turn my joints on, we can see that there is a skeleton inside here, and that skeleton is animated moving around. And so as far as the cape behavior, let's go and hide that, or hide the joints. And if I open up the outliner and I find the skeleton and open that up, we can see all the joints for the skeleton. And inside here we can see that we're going to have our cape geometry, meaning the original goal geometry. So notice that the cape geometry is parented to our skeleton, and so it's inside the skeleton hierarchy. So you just parent that cape next to the joints that it needs to be associated with, which in this case, the original geometry for the cape, if I go and let's sort of slide forward a few frames, let's get that geometry to be visible, and there it is. And we can see that that geometry is just parented to one of the top joints in the spine. And so it doesn't have to be parented, though. That original geometry could even be skinned to the skeleton if the original geometry needed to deform in some way near the top of the cape. But moving back in here, we can see as I hit play what the original geometry is doing. And so you can notice that the rest of the cape is just keeping up based on our goals. And so if I select the cape geometry, as you should expect, let's just switch to a different camera inside here. And let's grab that geometry and zoom in on it. If I grab the geometry for the cape and I go to the attribute paint tool, you will see what you should expect as far as the goals. The goals are all at 0 as far as the goal PP, and then towards the top of the cape we have values of 1. Let's go and hide the original cape, which is inside here, the one that's straight. So display, hide, selection, grab the cape, and then go to attribute paint tool. So by putting the goals at 1, it just means that the top of the cape is going to stay locked onto this area. Now he doesn't really have a cape that becomes 1 with the collar. If it did, if it was all one geometry, then let's say if this geometry up here was part of the cape geometry, it would just all have a goal PP of 1. but at this point we just need to do it along this top edge. And so you can see that you can start to be able to apply soft bodies to a variety of situations once you understand the concepts inside here. Let's go and hide the joints so we can just focus on the soft body result. So if you were creating something like this from scratch, and also be aware that we do have springs in here. So if I grab my springs, they have a stiffness of 300. And so I needed to get the springs to be relatively stiff so that that cape wasn't too stretchy, so that it would trail behind the character pretty quickly. But if I go into my edit oversampling, you'll see that I needed to have my oversample set to 2 so that I could have my stiffness be that high. And so if you were going to set something like this up from scratch and we deleted our soft body cape, and let's say we delete the spring node, we then would just need to get our original cape to be visible, which is going to be right here, display show selection, so that now if I hit play, we have this. Then I'm going to turn off my cache, my disk cache, and the cache is turned off by going to solvers, edit oversampling or cache settings, turn off the cache, and at this point I'm going to grab my geometry, go into dynamics mode, and then just say create soft body. Duplicate, make copy soft. The weight has a value of 1, and we definitely want to choose duplicate, make copy soft because the original is parented to the skeleton, and so the original you don't want to be affected. You want it to stay parented or skinned to the skeleton, so that the copy, the one with the particles, the one that you're rendering, is keeping up with the original geometry, which is skinned or parented. So if I hit create, now what we're looking at is our soft cape. The original cape has been hidden, but we're still getting the same result because all of the goals have a value of 1. But now what we can do is select this geometry, switch to a different camera, and then with the geometry selected, we'll go to the attribute paint tool. I can go in here then, flood it with a value of 0, and then we can go and set our per particle goals. We can choose to use artisan, as we did earlier, so I could go in and start to paint. I'm just going to lower things down a little bit so that the vertices up here all have high values. And so you may want to get this piece of geometry out of the way as far as this little shoulder strap, if it's blocking your view of your geometry. But now I can see that I'm pretty much getting all of it. And once that has been set, I might temporarily grab this geometry and hide it on a layer, just so I can select my cape geometry and make sure I painted the weights well. So now we can see that we do have values of 1 all the way towards the top. I can now close this, and if I now hit play, what we should expect to see is this, where the top part is staying stuck on with the original, but the rest of it is not moving. And so now what we clearly need to do is select this particle object and create springs. So create springs, and just like before, wireframe with a walk length of 2, and hit create. Now the springs have been created, so if I now hit play, we're going to see the geometry get pulled along. It's just going to take a long time for the motion from the skeleton to translate through all those particles down to the end of the cape. And so also you'll notice we don't have any gravity connected to the cape right now. And so I'm going to need to select those particles. And I actually already have a gravity field in the scene, which actually has a magnitude of 20. So we can see that I increased the gravity in the scene to get the cape to fall down faster. So let's use that same gravity field. So dynamic relationships window, grab the particles of the cape, connect them to the gravity field. Also, we want the particles from the cape to collide with the ground. So we'll select the ground, go to particles, make collide. For this, I'm not really going to want to have any resilience or friction. Maybe a little bit of friction, but not much. I have it at 0.05, let's say. Hit create. And then now go back to the dynamic relationships window, select the particles, collisions, NURBS plane. So now, we haven't changed the stiffness of the springs yet. All we've done is we've added gravity. And so we can see what's going to happen is that cape is just going to fall very quickly with gravity and just pull up on the ground and then get dragged. And so now we just need to go and grab our springs and increase the stiffness. And so we know that a stiffness of 300 worked, but let's see what happens if we put it to 100. and hit play. And again, remember that the display of the springs can kind of be distracting, so you might want to hide them. But you can see we're getting a result that's just too soft. It's bunching up on the ground, it's too stretchy, and also bouncy. I'm going to up the damping, and let's try a stiffness of 200. I put the damping to a value of 1. And so now it's hanging, but not quite as much. The result's getting a little bit better. Now what I'm going to do is now let's hide those springs, hide selection, but select them in the outliner. And now let's put the stiffness to 300 and hit play. And so with this, we can see that it's not as stretchy. It's following behind the character pretty well, but it is still really bouncy. And to reduce that bouncing effect, as we've seen, we can either rely on the damping or we can choose to rely on the conserve. So let's go and grab the particles and put the conserve to 0.9 and hit play. And now we're going to get a much better result. That's going to behave much more like a cape. And so maybe the conserve could be a little higher. Let's try 0.95 for the conserve on the particle node, so that the cape has a springiness to it, but it's not too exaggerated as it's hanging behind the character. And then for the particles, maybe I'll go in actually for the spring node and lower the damping now, because since I'm using conserve, I don't really need to use the damping. So it's going to be a big balancing act, which is always the case with dynamics, so that you can finally get the result that you want. And so at this point, we can see that we're getting the cape to work on our character. We can see the performance is pretty good that we're getting with the geometry right now. And so we're getting about 10 frames per second playback. And so let's just switch to our original camera. And we can see that we've pretty much rebuilt the effect from scratch, and it really didn't take that long. Maybe a little bit more tweaking with the damping, playing with the conserve a little bit more. But you can see that things are working very well and interactively. So that's pretty much it for this cape. So now let's go and try yet another example to apply Softbodies to. So at this point, we're going to move on to using Softbodies in conjunction with skinned characters. When we were setting up the cape, we saw that the geometry was able to be parented to the skeleton, and we at that point were able to go and turn it into a softbody to get the cape to work correctly. When you're dealing with characters that are skinned, whether it's via rigid bind or smooth bind or wrap deformers or lattices, however you bind the character, doesn't matter. After you've skinned the character, you can then go and add a soft body effect like we're seeing in the cheeks in this guy. And so this is something that's actually quite intuitive to set up, relatively straightforward, just like with the cape. And so if we jump out into the scene file, we can see that we do have a particle object. And in here, we can see that I've actually sort of lowered some of the goals down a little bit just to make the effect a little bit more dramatic. And what we're looking in here is we're seeing a soft body effect. The original geometry is skinned via smooth bind. And then also we can see that there's blend shape on the original geometry when he puffs his cheeks out, and we're getting a soft effect or dynamic effect as a result of that. We're using goals, goal PP painted via artisan, and then also we're using springs to smooth out the effect and to create more of a rippling type behavior. And so what I'm going to do is we're going to take this apart and basically put it back together again. And so if we go back and grab the soft body geometry, the one with the particles, I'm just going to go and delete that. I'm going to delete my spring object, and then I'm just going to grab the original geometry and display it. And so this is our geometry that's skinned to the skeleton. And so we can see that I'm able to scrub through the timeline without a problem. And even if I go in, I did have a cache on before when we had the soft body. Let me turn the cache off, and we can see that I'm still able to scrub. So we are actually looking at the original geometry that's skinned to the skeleton. So if I went in and grabbed one of my joints, we can see that I can go and rotate the joint around, and that we are getting our correct behavior inside here as far as our deformations. Also, we can see if I go and grab the geometry, there is a blend shape node on the geometry. And so I simply put a sculpt deformer inside the cheeks and scale the sculpt deformer. And so if we look to the right, we can see there is the blend shape target for our geometry. And so all of this is working together, and we can see that things are already skinned. And so we don't need to talk about the skinning really. We can see that it is smooth bind, however, if I go and select the geometry and in animation mode jump to edit smooth skin, paint skin weights, we can see if I start clicking on joints, what we're looking at is not goal PP weights, we're actually looking at just cluster weights via smooth bind. And so now that we have something that is skinned, but we do not have a particle effect yet, we don't have a soft body in the scene, what we're going to now do is select the geometry that's already skinned, and in dynamics mode, we're going to go to create soft body. And in the options, it's very important that you choose, again, duplicate, make, copy soft, because the original needs to stay the original, meaning that the original geometry is skinned to the skeleton. And the geometry that's skinned needs to be the goal for the particle object. And so duplicate, make, copy soft, hide non-soft object, make non-soft a goal, and we'll definitely put the weight all the way up to a value of 1 because we're going to rely on goal PP. So if I hit create now, what we will see is that we have particles which have appeared at the location of all of the vertices on this geometry. We're dealing with a NURBS head, by the way, which was modeled out of a single surface sphere, which I then used Artisan to sculpt the face. So it's all one object. And then if I go in here and hit play, now we're looking at particles. And so it's just, since the goal weight's at 1, the soft body version of the character is doing exactly what the original geometry is doing. So you can see that when the blend shape target gets hit, the particles of the soft body automatically assume that correct position. So now we do have a soft body, it's just we're going to get something that's exactly the same as what we had before. Be aware though that once you turn it into a soft body, if you grab one of your joints and rotate them, you're not going to see the result. So when you're dealing with a pipeline for working or animating a character that has soft bodies, what you're going to want to do is you're going to want to, whenever you want to animate the character, you'll just hide your soft body geometry and display your original geometry, the one that's skinned, so that I can go in and grab joints and rotate them and so forth. And so it's going to be very important that you go in and have a way to interactively deal and animate with your character. But whenever you want to go in and render, once you've set up the soft body effect, you then would go and hide the original geometry and just display your soft body geometry. So at this point, we already have animation in the scene, so now we just need to set the weights. And so what we're going to do is select the soft body geometry and go to the attribute paint tool, as we've done before. And so this time it's really important that we use Artisan, because trying to use the component editor at this point would be difficult since there's so many vertices on the geometry. Right now the entire geometry has become white because the goal PP is at 1 for all the particles. You're going to want, when you're using Artisan, to make sure that the wireframe is displayed. In the Artisan interface, in the tool settings, there's a folder called Display, and there's a checkbox called Wireframe, which I have on right now. If I turn off Wireframe, it becomes very hard to see what you're doing because everything's just a solid color. So I'm just going to turn on Show Wireframe to make it easier to get my bearings on the geometry as I'm painting. So with this character, as we saw, we just want the cheeks to be soft. And also, he has these kind of sort of nodules at the back of his head, which I also want to have or display a soft behavior. So what I'm going to do is you have to decide what the weight value have, or what the weight value is going to be that you're going to paint. Remember, the higher the weight value, the stiffer the geometry. And so I'm going to put the weight value pretty low. I'm going to put it down to a value of, let's say, about 0.4, 0.5. So if you have a very low weight value, what you're going to want to do is paint your gradations so that they're relatively soft. We're going to smooth them with Artisan, and then we'll use springs to keep everything together to create a better elasticity, as well as a rippling effect. As one region of skin moves, you want it to pull on the skin around it. And so now let's go on and paint. I'm using a brush that has a soft edge in Artisan, and I'm just going to start painting inside here, and I just make sure I'm in replace mode. I was in smooth mode. And so now that I'm in replace mode, I'm just going to start painting the parts of the cheek that I want to be soft. And so we're going to go in here and start painting. Now clearly, if you're dealing with a NURBS patch model head that has, a couple hundred patches, this is going to become very difficult because of the fact that painting with Artisan across multiple surfaces gets a little weird. And that's going to definitely be a case where you're going to want to either use lattices that you put for skinning and turn the lattices into a soft body, because lattices can be turned into soft bodies without a problem. Or what you're going to want to do is use wrap deformers, so that you can just have a single piece of geometry that you turn into a soft body instead of 100 of them. It's just going to make your workflow a lot more intuitive. For the back of the head, I'm going to go in here. I'm going to increase the weight value a little bit, just so it's not quite so soft. And I'm just going to paint this entire region gray, so that the back of the head is kind of soft. And so basically, as you're working with a character, you just sort of think, well, if you're dealing with a bony area like an elbow or a knee, then obviously you're going to want to have the very high weight values. In a region around an elbow or a knee, or a forehead or a chin, you'd want the weight values to be 1. But in more fleshier areas is where you can start lowering the weight values, like I'm doing inside here in this neck region. Also, at the top of the shoulder blade, it's very fleshy. Let's say along the lat muscle inside here, or rather the trapezius muscle. I'm going in and just sort of lowering the weight values down. But they're still pretty high, they're at 0.8. And now I'm going to go down to about 0.5, a darker value, and paint a little bit inside here, just so that it's going to be softer at the tips of these nodules. And so we can kind of see what I've painted. And then now what I'm going to go in here and do is just paint a little bit higher in the cheek. I just don't want it to go into the mouth region or the chin. And then I'm going to switch to smooth mode in Artisan. One of the paint operations we have inside this tool settings window is smooth. I'm going to set it to a value of 1. And then what I'm going to do is there's a button in here that's called flood. I'm going to hit that button, and you'll notice that when I hit the flood button, it's basically applying like a blur filter to the weights that you've painted. So I've hit that button about 10 times already. I'm continuing to hit that, and you'll notice that it's just smoothing out the overall effect that we're seeing inside here. So if I go to the back, I might want to darken the values down a little bit more. And then with smooth mode, you can also manually paint. So I can hit smooth, but instead of hitting flood, I can just paint. So just soften the edges inside here. And so now that I've got these softened, I can now go and test the result. So I'm going to close Artisan, and if I now move in here and we hit play, what we're going to see is we're going to have soft behavior. So just like that. So you can see this actually was quite a straightforward thing to do. So now we're going to notice that when he blows his cheeks up, we're going to get a little bit of a ripple inside there. It's subtle, but it's also only playing at 6 frames per second right now. But it's the clearest is really at the beginning when he moves his head to the side, and you can really see how those cheeks are moving. The only thing is that to soften the effect, it's going to look a little bit harsh around the edges, and so then we're going to go back to frame 1 and grab the soft body and add springs. So with the soft body selected, create springs, and in the options, since we're still dealing with the soft body, we're going to go and say creation method wireframe with a walk length of 2, just like we did before. I'll hit create. It's going to take a little longer than it did before to create the springs because we have a lot more vertices, but eventually we'll pop on and then we'll be able to hide them. And so here are the springs. Now I'm going to select the spring object and hide it. And then I'll select the springs again and increase the stiffness. Right now the stiffness is at 1, so if I hit play, things are going to look pretty much exactly the same because the stiffness is so low on the springs. And so what I'm going to want to do is take my springs and let's give them a stiffness of about 100. And so what you're going to end up doing is it's going to, even though we have low goal weights, the stiffness on the springs is going to keep everything together but keep things relatively fluid and natural. If you don't have the springs inside there, you're not going to get a rippling effect. Your regions of skin are just going to kind of move as a group or move as a unit. So you can get nicer results by lowering the goal PP, but then adding springs with a high stiffness so that you can get geometry that's going to be very jiggly. Like if you had a really fat character, for example, you want it to be very jiggly but stay together naturally. You need that ripple effect with the springs. If we want to see this behaving a little bit faster, we could go and cache it, or we could choose to go and do a play blast. Let's just do a play blast real quick. I'm going to make a new camera just so we can go and come in a little bit closer in on the cheeks, and then we'll do a play blast. And we can see the result. So in this case we did it on the face, but we could just as well have been working on an arm, a shoulder, a pectoral muscle, an abdomen, a thigh. It's going to be the exact same workflow that we just did. So you have a character that's already skinned, and then you go in and take the geometry and turn it into a soft body. If you skinned your character via wrap deformers, you would just select the wrap deformer and turn that into a soft body. If you skinned your character via lattices, you'd select the lattice and turn that into a soft body. The only thing to watch out for if you're using lattices that are soft bodies is that you won't be able to use Artisan to paint the goal PP, because Artisan for painting goal PP only works on geometry. So for wrap deformers, which are usually going to be polygonal objects, Artisan works fine. So all the things that we've been doing with NURBS objects works just as well with polys. If you're dealing with subds, you're going to not turn the subds directly into softbodies. Again, you'll use a raptiformer technique, which really is the most efficient workflow, so that you create a raptiformer, apply that to the subd, skin the raptiformer, turn the raptiformer into a softbody. So that pretty much covers the face setup in here. Let's just sort of hit escape so we can see the play blast. And so at this point it's playing pretty much in real time, and we can see in the cheek we're getting a nice follow through inside there. Notice that when he blows his cheeks up, that we do get this subtle little ripple inside there. And even when his cheeks go down and blow up again towards the end. And then if you decide in here that the cheeks are like too soft, they're moving too quickly, you just increase the goal PP. We painted the goal PP with a value of 0.5. So you then would go in and maybe try putting a value of 0.6 to gradually start increasing or decreasing the movement inside there. And so, because we can see the areas that have a goal PP of 1 are really not moving at all. And so it would just be a matter of going in, selecting the geometry, going back to the attribute paint tool, and then increasing the goal. So right now in here we can see that it all has a value of 0.5 that we painted. Maybe we'll put this to a value of 0.7 and then start painting in replace mode to lighten the color. And by lightening the color, that means that it's going to not move as much. It's going to be stiffer. And then once I've lightened the color in here a little bit, I can go to smooth mode, soften the edges of what I've just painted, and then we could do another play blast. And so it's really a very interactive process to go in here and work with this. So hopefully this all is pretty clear. It's rather intuitive once you understand the concepts of goals and springs and their relationship to each other. And these particles, again, are normal particles, meaning I still have my conserve attribute that I can use, and any fields could be applied to this character, meaning that gravity could be added, so if the character walks around automatically you get the jiggle and the bounce and the flesh. We could add air fields if we needed wind to blow the character's skin. We can have collision objects if we need a character's skin to get touched by another character and it needs to indent as it gets touched. All of that stuff is going to work well. And so there you go with this face.